Okay. Blockchain technologies, I call blockchain technologies basically any technology that got inspired by Bitcoin. So Bitcoin came along in 2008, and since then, we have first had many other cryptocurrencies, altcoins. Then we had other blockchains, other setups of blockchains. We had Ethereum and smart contracts. With smart contracts and cryptocurrencies and tokens, we got, of course, the fungible tokens, non-fungible tokens, we got DeFi, and we got DAOS. So many different technologies that kind of go back to this inspiration coming from Bitcoin, and all of them together I would call blockchain technologies. And as each generation of this each new generation of blockchain technology comes along, starting with Bitcoin 2008, they all promise decentralization, disintermediation, democratization, leveling playing field for entrants, and altogether that should bring improved creation of value and improved distribution of value. So in my research broadly, I ask about each of those technologies, or many of those technologies, to what extent and under what conditions do they indeed deliver on these dimensions. And also, it turns out that disintermediation and decentralization are different things. It's useful to distinguish and kind of dig into when and whether blockchain technologies deliver. It turns out that sometimes they do and sometimes not exactly. And this is useful if we want to apply them for large-scale practical applications. So in this talk, specifically, I will be talking about tokens among many different blockchain technologies, and specifically talking about how they affect platform economics. And this is because tokens and smart contracts and tokens and blockchains allow for new design choices in platforms. When we set up platforms, we can do more with those new technologies. And the question arises whether those new design choices can help us solve old problems that we have in platforms and in platforms economics. So the old problems, or the main problems in platform economics, come from network effects. So we have network effects when a value of a good or a product is increasing as more other people are using this good or product. I mean, those are typically positive network effects. We can have congestion, which is a negative network effect. And this is when the value is decreasing as more people are using the same service or product. But here we mainly talk about positive network effects, and this is when the value is increasing. So platforms specifically create value by bringing users together. And social media like Facebook, they bring people together to interact. Uber is bringing different types of users, so drivers and passengers. And again, the value here is created by bringing them together. And the more other users are on the platform, the larger is the value of the platform. And this is basically coming from network effects. And this gives a very specific dynamics to platforms that is not necessarily present in other type of goods. So nobody really wants to be the first user on Facebook. Facebook is fun, but being a first user just really does not bring you any benefit. And if there's any cost of joining and learning the software and the platform, then it's really not much to do. Nobody wants to be the first passenger if there are no drivers. Nobody wants to be driver if there are no passengers, and so on. So potential users want to join a platform if and only if others join as well, either whether they have already joined or we expect them to join. And again, this is why it's different. Goods with network effects, where platforms are predominant, are different than typical goods that have their intrinsic value just from being there. So the result of this dynamics, I want to join if and only if other people join as well, is that network effects make it difficult to enter the market. If a new platform wants to enter market with network effects, either they need to enter big, or they will probably fail to enter. It's really difficult to start Facebook with just 3 people. You need to start with most of the Harvard population, and then you want to grow very quickly to have a critical mass. The same with Uber. You need to sign up drivers and passengers before actually you go live, and it's often hard to do. But once you succeeded as a platform and you enter the market, and you're a large-scale market, you're a large-scale platform like Uber or Facebook, then in fact the same network effects create barriers to entry for your competitors, and that will allow you to enjoy a huge market power. And this way, network effects create powerful intermediaries that are able to extract value from the system. So, the ongoing debate that we have right now in policy is about Facebook being able to extract data, other platforms being able to charge either high prices or put some difficult conditions on the users that allows them to extract value. So right now it's mostly about data, but you can also imagine high prices. So AT&T, when again it's an example of a network and a platform, was charging really high prices for long distance calls. Okay. So the question arises, or we are curious to see whether blockchain technologies and specifically tokens would help us solve those 2 problems. So specifically, the tokens, the tokens have been around for a very long time. Tokens, old word. But what is new about tokens in the context of blockchain is because tokens enabled by blockchains and smart contracts allow for commitment. So they allow for 2 features that we are exploring in this research. And one is the fact that the platforms can commit to certain use of those tokens or acceptance of these tokens, or restriction on those tokens. And at the same time, the tradability of those tokens is independent of the platform. So what we see right now is you have tokens issued by Helios or Filecoin that can be traded independently of the platform that issued it. And this is because they are blockchain based, and almost any cryptocurrency exchange are going to be helping you with exchange of those tokens. So those are 2 features that are differentiating the tokens in the context of blockchain from the old-fashioned tokens that any platform could issue, but they were in full control of it. Okay. So we will be exploring 2 types of tokens. One type is utility tokens, and the other is governance tokens. So what we show in those 2 papers is that once utility tokens make entry indeed easier. So if the platform is issuing utility tokens rather than just charging straight out prices, then it's easier for them to enter in the presence of network effects. And second, the governance structures that are enabled by governance tokens, so-called DAOs, the centralized autonomous organizations, allow for more value creation and more equitable value distribution. So both of those findings are very welcomed by blockchain community, because it shows the ability of blockchain technologies to improve on the old economics problems. At the same time, we're showing that each of those findings comes with its caveats. So first, utility tokens make entry easier, but they lower the overall platform's profit, and they decrease the overall welfare. So it's benefit on one side, but it comes at a cost. And DAOs may lead to socially improved outcomes, but only for narrow and limited conditions. And otherwise, we actually still have the same recentralization incentives, and the tradability of governance tokens may lead to actual recentralization in equilibrium, and in effect value capture, but maybe now by anonymous users. So this may be different, or maybe even worse than value capture by parties that may be regulated or brought to court. So in the end, overall, what we are arguing is that tokens may alleviate, but they do not fully remove traditional concerns. And knowing the conditions when they are useful and when they are helpful and when not necessarily, it will be helpful for judging whether tokens are a useful tool to be implemented in applications or not. So let's first start with utility tokens and the platform entry. And here, the inspiration for our research and great examples at the same time are examples of platforms like Filecoin and Helium. So Filecoin is a peer-to-peer competitor to Dropbox, to file storage, it's a peer-to-peer file storage system, where you need users who are allowing their space on the computer to be used for storage of other people's files, and you need people who are willing to pay for this storage, and they are using the system and paying those who are providing the storage. With Helium is a peer-to-peer hotspot network, or the peer-to-peer internet system that is especially intended to be used for IoT devices. And the way it works is you have people allowing the system to be using their hotspots, at least to some capacity, and altogether it can connect large spaces and allow for connectivity. So it is easy to see that network effects are really strong there. The system is only attractive if there is a large number of users who have already joined the system. So of course, with just few people offering their storage space, or just few people offering their hotspot capacity, the systems are not useful at all. Okay. And both of those systems, so Filecoin, the way it was designed right away to use tokens. But Helium is a great example where initially they had difficulty to get off the ground and enter the market, so to say. But later they decided to use cryptographic tokens, and with those cryptographic tokens, they successfully took off the ground and are an active network at the moment. So. Like I said, in both of those cases, we have network effects and potential users want to join if and only if other users join as well. And this leads to multiplicity of equilibria. So either everybody adopts because they believe that everybody else adopts. So think about everybody standing in line for iPhone in 2007 because they assume it's not only going to be a great product, but it's going to have a lot of apps. Or nobody adopts because they believe that nobody else adopts. And here you can think about multiple attempts for Google to create social media with Google Plus and a couple of others, where people were just not joining because their friends were not joining and they didn't expect to join. So you can have, in many cases, we have examples of technology that may be just as good technology, but this kind of expectations can kill or make technology successful. And this is what we call coordination problem, because it goes back to the old-fashioned coordination game, that just two equilibria. And this observation for markets with network effects has a long history, going back to Katz and Shapiro in case of one-sided networks, or Caillot, Julien, and Rochette and Tirole in case of two-sided platforms. The traditional way to solve this coordination problem is SUBSIDY. So this is a divide and conquer strategy. It's often referred to as conquer and divide strategy. And basically, it means subsidize early users and then profit from those who join later when it is clear that the platform is successful. And because you can charge high prices later when the product is successful, when the platform is successful, it actually makes sense to subsidize early users so that they join and try your platform. So there are many examples of that strategy being used. So my favorite ones are PayPal and Uber, because they basically would give you a $10 credit if you join the network. So if you're an early user of PayPal, you would get $10 to spend. And similarly, Uber, if you set up an account, they would give you $10 to spend on the rides. And they were basically paying for it because you did not need to pay for this $10, and somehow it needed to be paid. So it is a very successful strategy. The problem with that strategy is that it requires upfront capital, which may be expensive, and it creates barriers to entry. Because if you come with this idea of peer-to-peer hotspot network or peer-to-peer file sharing, and you want to go and get VC funding or a bank loan, you may be in trouble, or you may be you will need to pay very high interest rate on this. Okay. So our initial question when we were seeing a lot of ICOs and later even more activity in utility tokens, we were wondering with Yanis whether these tokens may help us to overcome the coordination problem, may help platforms to overcome coordination problem in a more effective way than SUBSIDY. So we built a simple model that most of the technicals I will skip, but I will talk about the result of the model, the findings that come from the model. So with SUBSIDY, right, the platform basically sets the price every period, right? So we play a game of joining or not joining the platform. Every period, there are new people coming to the market, and they need to decide whether to join the platform or not. And with SUBSIDY, the platform sets the price for each period, and the price may be negative. And especially, if it's negative, this is when the users are subsidized, and this would be typically early users that are subsidized. And then in later periods, the price increases. So some of those early users, and actually any user, when they join a platform, they may not be fully aware of how much they will like the platform, not until they try it. And especially when it comes to a new platform. So they come to a platform, they were subsidized, so they tried it, but they decided that they don't like it and they leave the platform. If they leave the platform under subsidy, they get zero. They basically get their outside option zero, and they go on to other things without this platform. But instead of subsidy, right, the platform may issue utility tokens. And utility token may allow you to access the platform and to access platform services. And presumably only with those utility tokens, you can indeed access those services. So here, Helium is an example, Filecoin is an example, and a couple of others. The platform can set the price in the first period, early on, when they first sell the tokens, some number of tokens, they can basically set the price for a token. But in the future, what the platform will do is the platform will set a number of additional tokens that they will issue, if any. They may commit to future issuance, but they don't need to commit to future issuance of the tokens. But the price for the token will be set on the market, because the tokens are tradable. So users who don't want to keep using the tokens, they may sell the tokens in the market. And then there will be supply and demand. Okay? So users who exit can sell the token. And in expectation, the price for the token will be positive. So I emphasize in expectation because we may have some uncertainty, but on expectation, it will be positive because even though the platform may set an arbitrary number of tokens in the future to issue, the platform will never want to issue so many additional tokens that the price is going to drop to zero. And this incentive of a platform is giving not guarantees, but expectation for the users that their tokens will have positive value if they will want to sell. So before going on and looking into the outcome of these forces as they are playing out in the market, upon setting up this, setting them up, I want to emphasize two features that are coming from smart contracts and the blockchain positioning of the tokens. So first of all, platform can commit to accepting the tokens in the future. And this can be done via smart contracts. And this could not be done with tokens before, because you can imagine that tokens, type of utility tokens that give you platform access, could have been issued before we had blockchains. But with smart contracts, the platform can commit to accepting the tokens in the future. So if I bought a token from somebody else, it will be honored. And second, a platform cannot interfere with trading because trading is happening on external blockchain. And those two features of blockchain tokens will be crucial in taking advantage of those tokens in equilibrium. And the reason why the blockchain tokens are different is because without those two features, we could not take the advantages that we'll be able to do with blockchain. Okay, so let's see how it plays out. So, and whether those utility tokens are better than subsidy, where the utility token gives you platform access. So the crucial point in the dynamics that is differentiating the tokens from subsidy is that a user who exits the platform can resell the token at the positive price in expectations. Okay, and it allows the platform to increase the price and their profit when they enter. And then this is because a user can say, well, if I don't like the platform, then if I exit, I get something out of it. So on expectation, trying the platform is lower cost, even if there is cost to trying the platform and setting, learning the software and everything, they are willing to join at the lower subsidy, and maybe even subsidy is not needed. And maybe even in situations where before with subsidy you needed to pay $10, you may actually sell a token for $2. So it may completely flip the sign of the price in the first period, exactly because of those expectations of future profit if I don't like the platform. And if I like the platform, that's even better. But there is a downside of this issuing the tokens, and this is that the tokens lower the profits in the future for the platform. And this is for two reasons. One is, in the second period, the platform sells fewer new tokens than they would sell new access rights under subsidy. And this is because some of those new users are actually going to buy the tokens that are being sold by the old users, early users that decided they don't like the platform. So there are fewer tokens, fewer access rights that the platform is selling. And at the same time, the price at which the platform can sell this access to the platform in the later periods is lower than if they would be selling it under the subsidy. And this is because this additional supply that comes from so it actually comes from two sources. One is the additional supply that comes from the resale tokens is putting pressure on the price. And second is there is actually smaller network in the future periods because more users want to exit. And this altogether clearly is lowering the price of access to the platform in the second period, which may be good for new users who are joining, but it is bad for platform, especially that they are selling fewer access, right? So I want to kind of point out that both of those forces could be shut down if the platform would renege on accepting old tokens, the resold tokens, or they would limit trading. And this is for that reason, the platform has very strong incentive to renege on accepting or limiting trading. And this is why without blockchain technologies and commitment, we would have difficulty to see that really going through. But if the platform shuts down the second period disadvantage and users expect that the platform is going to renege or limit trading, then the whole benefit of the first period is gone, because the only reason why there's a benefit in the first period is because users expect to sell the tokens at the positive price. And I see there is a question. So Brian, can you just ask the question?
Sure. My question is, if token has value attached to it under certain expectation for profit, our tokens will be treated as securities by regulators. What will be the impact or net effect on a platform or community when tokens are treated as securities?
So, the first point that to make is that there may be a positive price, but it doesn't need to be increased price. So there's a difference between I'm selling you a token for $2 now, and you may expect to I mean, you probably, so let's say you're getting a token for free and you can expect to sell it at $1, or you may expect to sell it at the same price, but it will be positive price, which means that it is going to be higher price than 0. And with subsidy, you're getting 0. So it's not necessarily the price is going to increase. A second is there is, of course, this battle, whether it's security or not. And the argument among, within tokens and blockchain community is these are utility tokens. And just like timeshares on your holiday home or vacation home that you can trade, just because you can trade something at the profit is not considered a security just by itself. So there is, of course, divided opinions whether tokens are securities or not. Here you can claim that you are primarily buying it to access the platform, and you are selling it because you didn't like the platform. Now, in the model, we also add speculators, but we are not looking at the effect of the taxes if you have speculators on the tokens. So the second answer here is that if you have tradable tokens, you can never completely disentangle the utility value of the token and the security value of the token.
Thank you.
Okay. So, so right now we have those two competing forces. We have this higher profits in the first period due to tokens and lower profits in the second period due to tokens for the platform. So the question is, which way does it go altogether, right? When we sum it up, can it even out, or can it be that the first one outweighs the second, or the second outweighs the first one? So it turns out that the second will always outweigh the first one. So the overall profits for the platform will be lower. And moreover, the overall welfare will be lower. So the reason why the platform profits are lower intuitively, if the overall welfare is lower, and in fact, as I'm going to show you, the users are getting a bigger chunk of this welfare, then there's just less to go around less left for the platform. Okay, so why is the overall welfare lower? And this is because resale encourages user exit to a larger extent than subsidy does. Because if you exit and you get 0, fewer people will exit after trying the platform than if they will, if you can get $1 for your exit. And that means that there will be some people who will stay on the platform and still contribute to the network effect, even if it's on the margin. So that means that the overall network is going to be smaller in the future as with tokens as more people leave. Okay? So this is why we are going to get overall welfare to be lower. And a lot of this welfare is going to go to the users because they are reselling those tokens. So tokens do redistribute welfare from the platform to the users, but not evenly. Not all the users are benefiting. So users who exit in fact are getting more out of tokens than if they would under the subsidy, because if they don't like the platform, they can get something out of it, whereas if they didn't like the platform, they would get zero under subsidy, and they are benefiting the most. The users who stay are either weakly or strictly worse off, because now they will stay with a smaller network. They will get less of the network advantage under tokens than under the subsidy. So again, smaller welfare, more welfare going to users, and therefore smaller profits to the platform. So will overall cryptographic tokens issued on blockchain help to overcome the coordination problem for new entrants, right? From the insights from our models show that tokens make it possible to reduce or eliminate early user subsidy, and that is making it easier to entry for the platform. But they do it so by moving the revenue from the second period to the first period, and the overall profit will be smaller if there is no cost of capital. So if we just look at the movement of those profits between the periods, then with no cost of capital, the overall profits will be lower with tokens than with subsidy. But it is possible that if there is no access to capital, or the cost of capital is high, then in fact tokens are attractive, because if there's no access to capital, tokens may be the only possibility for a platform to enter the market at all, right? So yes, with subsidy we would have made more money, but there is no subsidy, so this is the only way to enter the market. And that may explain why the most activity and platforms that are actually using successfully tokens that are freely tradable are platforms that use very novel technologies, or they are using peer-to-peer systems that would be difficult to get initial funding for, and Uber and similar platforms that are more established, and they have, or even competitors to Uber that may have a better access to capital, they will not go for those tradable tokens, and they don't find them so attractive, because setting up tradable tokens is actually not a difficult thing. What is difficult is setting up a system that proves a commitment to accepting those tokens in the future and unhindered trading of the tokens. But that could be done if it was profitable for the likes of Uber. So this is the conclusion for the utility tokens. And I want to ask whether there are any questions or comments on this part before moving to the governance tokens and value creation distribution.
So you mentioned the possibility of incorporating speculators into the model. How does that change any of the insights, if at all?
So yes, so we have in the model, we have in Appendix F, we have speculators. So what happens with speculators? They make those results stronger, because what happens is that they move even more of this profit from the future to the present. And then they put even more pressure on the price as they are selling those tokens in the future. So speculators are going to come in only if the price in the future is higher than the price today, and they are going to even out the price on expectations. But that is going to strengthen the result. That is actually it's going to bring more profit to the present at the cost of future, and the profits will be even lower. What we did not incorporate is any regulatory aspect of the fact that speculators now may be under different tax regime.
And is the possibility of the platform sort of say buying back its own tokens and so on sort of incorporated into the model, just in terms of the platform being the one that issues the tokens? So can they also, like in a multi-period model, sort of play with the system by buying back the tokens that they've issued earlier, would that make any difference?
Yeah, so they can. So they are allowed to issue additional tokens, and they are allowed to buy from the market the tokens that are already existing, but they need to buy at the market price. So yeah.
Okay. Thank you.
So the second type of tokens that we considered, and this is more of an ongoing work, but with very interesting insights, are tokens, are governance tokens that allow for voting, and their effect on value creation and distribution. So examples of governance tokens are used in DAOs. Those are the governance structures enabled by governance tokens that I mentioned earlier. And there are many examples of DAOs that have been quite successfully working. Maker is probably the most highly functional DAO in the sense of the number of decisions that are being made in a decentralized way. Uniswap is an example of a DAO, but it is not as much as decentralized as Maker DAO. But there are many other. There is SushiSwap that is also has the elements of DAO and many more. So the DAOs are set up on smart contracts because they allow for voting through governance tokens and making decisions in a decentralized way, or by voting among a large number of people, and those decisions after the vote can be automatically implemented via other smart contracts into the model. So specifically, the DAOs promise to prevent the value capture by powerful intermediaries, because they say instead of having centralized intermediary that can now charge high prices because of the network effects or creating the market, we can, by giving the decision rights to the voters who presumably are also users of the platform, they will not have incentive to extract the value, and that is going to prevent this value capture. Okay. And as other blockchain technologies, this is done by decentralization, disintermediation, distribution of value otherwise captured by centralized intermediaries. And typically, DAOs are set up in a permissionless environment, because if the environment is permissioned, that it gives someone authority to exclude users from the DAO. And the point of DAOs is to have a decentralized system without authority who could capture the value. Because if you have the power to extract people from the DAO, you may maybe ask them for payments, not to exclude them. So we show that these promises of a democratic DAO actually do hold, but only under narrow conditions. And in more general conditions, the forces towards centralization are quite strong. And they can make platform intermediaries controlled by democratic DAOs difficult, if not impossible, in the long run, if we account for tradable tokens. So we argue that some additional safeguards may be needed to sustain this type of disintermediaries, as we call them. So as we are in the early stages of DAOs being used more broadly, maybe we should think either of regulation or just the best conduct ethics for DAOs. Okay. So here I want to show our point about centralization forces via an example. It's going to be a very simple example. So imagine that we have n potential platform users, and everybody has a each with a type K distributed uniformly on 0, 1, and they have varying utility from participation, and their type is their utility. So it's that the utility is distributed between 0 and 1 uniformly. So that gives us a textbook example of a 45-degree demand curve, and this is why we chose this this particular example to illustrate it here. And then in such a market, a monopolist that comes and sets the price will set the price to 1/2, serve 1/2 of the market that's going to maximize the profit. And it is going to create a dead weight loss because half of the users will not be served and the sum value will be extracted. So let's consider an alternative where a DAO is the intermediary in the market and the DAO is setting the price. So here we focus on the price decision because this is a clearest textbook decision and it's going to make our analysis clean. But it could be any value extracting decision. It could be a decision whether to sell our data or whether to allow advertising in or so on. So consider a DAO where there is no central authority making the pricing decision, but instead all potential users get a governance token and they use this token to vote on the price P that will be used to access the platform. Okay? Potential users decide, so once the price is decided by the DAO, the users decide whether they want to pay the price and join the DAO, or they are not paying the price and not joining the DAO. Now, if the price is positive, there is collected profit, and the profit is distributed to the token holders as a dividend. So in this system, a DAO could vote for price to be 0. At this price, everybody joins the platform, everybody gets the utility from the platform, the social welfare is maximized, and there is no dead weight loss. Okay? So DAO could decide on that, but will they actually vote on that price? Okay? So first, let's notice that some of the potential users with really low utility of joining the platform, they will actually prefer to vote for high price and collect higher dividends rather than set low price and join the platform. And if I know that at the platform, the higher price of the platform, I'm not going to be using the platform, I want to set the price equal to monopoly price because I want to maximize my dividend. But if I know that I will be using the platform, actually the price that I will be paying outweighs the dividend. So I want to set the price to 0 and not pay the price and not get the dividend. So Brian has a question. Whether there is an optimum size of a DAO in terms of number of participants for effective coordination. So here I'm actually not going to be looking at, in this example, I'm not going to be looking at the coordination on their decisions. Everybody is going to vote, and everybody will have rational expectations. And there will be no coordination decision. So in voting for prices, there is no coordination problem, turns out. So I think, Brian, I'm not sure whether I answered your question.
Yeah, my question is basically in terms of decision makings, not really for price, for any kind of a future in terms of governance voting, because there could be if there are too many people have disagreement, there will be undecisive and ineffectiveness of the organization. So there's a saying maybe there's an ultimate group of people, either you delegate your votes to somebody else with more expertise or more skills, and to make a better, more educated decisions rather than everybody to get involved. That's what I mean.
Oh yeah, so this is a serious problem in DAOs for sure, and in democracies for that matter, is that if you have everybody making decision and they need to get information to get the decision or education, they may not have an agreement on how to reach the same outcome. So here it will be much simpler than this. Everybody can perfectly calculate what price they prefer. And so you can imagine that this is a voting among informed users or potential users. So they are all informed, but they will have different preferences. So this is a different problem that we have in DAOs, is even if everybody is informed, if we are making a decision about something that is just easy to know what your preferences are, we will have different preferences, and that may end up with a decision or either indecisiveness or a decision that may not be optimal for or socially optimal.
All right, thank you. Please proceed.
So so here we'll be just looking at the prices, and everybody can easily figure out which prices they prefer, which price they want to vote on. Okay, so here basically it's either price 0 or price 1/2 that will be put up to vote. So Brian, another thing about reaching a decision is all votes are pairwise votes. So you are going to just have there will be no cycles or anything like that. It turns out not to be a problem here. And yet there are other problems. So if we look at the green line is showing us a utility of a different type of a user when the DAO sets the price to 0. So 0, and therefore everybody joins. The utility of a utility coming from it's a utility coming from dividend. When the platform when the DAO sets the price to monopoly price, and we can see that for 1/4 of the users, they will prefer the monopoly price, and for 3/4 of the users, they will prefer the 0 price. So if we have majority voting, the DAO in majority voting will set the price to 0, which is socially efficient price, and this is exactly what we would expect the DAO to do, and this is where we are putting our hopes in those decentralized organizations. Like Brian, according to as long as everything works well and everybody is informed and everybody votes. Now, the crucial aspect of this outcome is that every potential user has and votes with 1 token. So tokens are evenly distributed here, but in reality, the governance tokens are tradable. So if we account for tradability, the outcome may change. So if everybody can buy more than 1 token and they may decide how many tokens to buy, then they also need to think about what will be their payoff if they have multiple tokens. So for a user somebody who at the price decided by a DAO will decide to use the platform, their utility will be the usage utility equal to their type minus the price that they pay plus T times the dividend that others pay. So what you can easily see right away is that as the number of tokens that I hold is increasing, it becomes more important how much other people pay. I want them to pay more, and it becomes more important than me paying less. So I may start preferring a higher price as I own more tokens. Right? So first, we notice that if the price set by the DAO will be positive, then the governance tokens will command a positive price because of the expected dividend. Okay? And so I may be willing to buy more and more tokens just because I want the dividend if the price of the token will be lower than the dividend. Okay? It turns out that if a user finds it profitable to buy 1 token at the given price of a token, then he will want to buy all of them. And this is kind of an interesting finding, that the value of the tokens is actually increasing the more tokens you have. Okay, and this is the first force of centralization. So basically, if you have just few tokens, then each token is worth the dividend. So if the price is lower than dividend, you want to actually buy all of them. Why not get all the dividend? Okay. But if you suddenly have majority of tokens, you will be solely responsible, solely setting the price. You will set the price, and you will set the price higher the more tokens you have. So maximizing this utility, this payoff expression with respect to the price for a given number of tokens, the optimal price is given by this formula, right? And you are going to be increasing the price as you have more tokens. And that means that you are going to have you are willing to pay not only more for addition for the next token, but also the tokens that you already have are going to give you higher dividend for every token that you already own. And that together means that each token acquired is worth weekly more than the previous one. And that means that everybody will want to buy all the tokens. Either they don't want to buy any tokens at a given price, or they want to buy all the tokens. So this is for the users. The non-users will value each token. If they are controlling a number of tokens, they will prefer to pay monopoly price. If they can, either the dividend price, which is less than monopoly, or a monopoly price if the DAO is going to set the price to monopoly, or if they control more. But in both cases, this dynamics that the more tokens you have, the higher is the value of the next token holds at least weekly. So that means that everybody wants to buy all the tokens. Let's imagine that we have a situation that those all potential users are bidding for all the tokens. Who will be the highest bidder? So it turns out that the non-users will want to bid the profit value. The users will have even higher willingness to pay. And the user with the highest type will have the highest willingness to pay. If allowed, the user will buy all the tokens. And having all the tokens, he will set the price equal to this formula, which is just slightly lower than monopoly price. So even though this is exactly the user that has highest incentive to set the price to 0, if he has one token, he has incentive to set almost monopoly price when he has all the tokens and capture the value. Okay. So basically what this example illustrates, and we have a general model showing that it's even more striking with strong network effects. Then what it shows is that when agents are differentiated, few or one will have higher willingness to pay for the tokens than the rest of them. And value of tokens are increased the more tokens you already have. Both of these things are going to lead to concentration. And if we have concentration, then it actually increases the price that the DAO is going to set, because even the same users who wanted to set low price now want to set close to monopoly price. So we may end up with the same value capture in this decentralized system than what we have experienced with the previous technology that was promising decentralization, disintermediation, and democratization, which was the internet. Right? We had a period of decentralization, and after that we got Facebook and Google and Amazon. Okay? There are ways to there maybe thinking about ways to prevent it, but all the ways come with caveat, and therefore they have their own issues, and I'm happy to discuss them afterwards. For now, let me just kind of wrap it up and summarize. So we have been looking at how platform economics is changed by blockchain technology, and specifically the tokens. And blockchain technologies offer new solutions to old problems, but they may come at the price or not work as expected. And specifically, we looked at utility tokens that may improve viability of a new platform, but at the cost of overall profits. So that means that there is still room for banks and VCs. Tokens work, but they are not going to displace the old industry. And governance tokens may allow for decentralization and increase welfare, but they do not remove tendencies to re-centralize and extract surplus once the platform is re-centralized. So without additional safeguards, it may lead to the same powerful intermediaries. So with that conclusions, thank you very much. And I want to thank you for your comments and questions.
Thank you very much, Professor Hanna, for a wonderful presentation. It's very insightful, and I think it comes at the right time when there is so much discourse about the power of DAOs and how blockchain could change lives forever, and how DAOs could make society better. I think your presentation definitely makes people rethink about those claims. Yeah, so I know that we are on top of the hour, but maybe let's just ask the audience if they have any questions.
Do you think, Brian, you have another question about how
Yes.
they are? Yeah.
Yes,
Go ahead.
I was thinking about how, I don't know if you ever make any comparisons or analysis on the similarity and differences between DAO and the co-op business. Because
Yeah. So they are very close. So in fact, DAOs are supposedly close to co-ops, except that co-op shares are not as easily tradable, right? Because with the moment you get a voting right, you need to do some work. Right? So you cannot so easily decouple the dividend from the benefits from the usage. So one thing, and second, it's not here. We are going to have a much large scale and anonymity involved. So a lot of the positive aspect of co-ops is that you can enforce a lot of social norms because in most cases people know each other. And it's a repeated interaction. And with DAOs, this is not the case.
I see. Got it. Thank you.
So I think that this is exactly the right comparison. Yes.
Thank you.
Yeah. So Professor Hanna, I think there is someone asking if they can get a copy of the slides.
Yeah, I'm happy to send it to you, and then you can forward.
Okay, great. And also the recording is going to be available on website. So if you follow Blockchain UBC's LinkedIn account, you will see the recording as soon as we post it.
Thank you.
All right. So thank you again, Professor Hanna, for the wonderful presentation, and it was lovely to learn from you. And hopefully one day you could come visit us in Vancouver, and we will be very honored to host you here.
So thank you much for having me, and yeah, I'm looking forward to a person in visit. Sorry, to a visit in person.
Okay.
Thank you.
Okay. Thank you everyone for joining, and have a great day.
Thank you.
Bye-bye.